So, hi everyone, today we are gonna be solving October-November 2024 paper 21 of OLevels, and as you know that practice makes a man perfect, so we're gonna be practicing past papers every day and try to follow up with the next videos in which we're gonna be solving past papers every day, and that's gonna get you a good grade and good hold of your concepts. And please consider subscribing to the channel, that's going to mean a lot. Let's get started with the paper. Okay, the first thing I always tell people in chemistry, it's very important to understand what's written. Okay, in a hurry, don't miss out the important bits, the important details. Okay, figure 1.1 shows the electronic configurations of 5 atoms D, E, F, G, and H. Okay, we have 5 atoms. Answer the questions about these electronic configurations. Each electronic configuration may be used once, more than once, or not at all. Okay, now looking at these atoms, being an O-level student, you can just deduct or extract some important things. This one right here has 2 electrons in its outermost shell, so this must be a group 2 element. Okay, this atom must be in group 4 because it has 4 electrons in its outermost shell. Okay, this is in group 4. This one right here is in group 0, or you call it group 8 or noble gas because it has a full outer electron shell. 1, 2, 3, 4, 5, 6, and 7, 8. G1's in 1, 2, 3, 4, 5, 6. It is 6 electrons, so it's in group 6, and this one's in group 1. Okay, I hope this one's simple, and because you're given with a periodic table as well, so you can just, by counting the number of electrons, basically you can tell which atom is which element it is. How? Because look, I know that if I count the electrons over here, which are 6, okay, 1, 2, 3, 4, 5, 6, I have 6 electrons. I know that in a neutral atom, I am going to have the same number of protons as electrons. So I'm going to have 6 protons because this is an atom, not an ion. I'm going to go to the periodic table. I'm going to check which atom has 6 protons, and that's going to be my carbon atom. So I know this one's right here is carbon. As simple as it looks. Okay. Answer the questions about these electronic configurations. Each electronic configuration, okay. An atom of an element in group Vi. Vi means 6 of the periodic table. Obviously, that's going to have 6 electrons. It's an outermost shell. 1, 2, 3, 4, 5, 6. That's going to be G. Okay, an atom that forms an ion that gives a lilac color in flame test. Okay, these questions can be tricky for some, but not for the smarter kids. Why not for the smarter kids? Because look, you know that lilac color is going to be given by potassium, because you guys have learned the flame test. You know lithium is going to give you red, sodium yellow, lilac is going to be given by potassium, then orange green by calcium, light green by barium, and blue green by copper. So you know this is going to be potassium. You know that potassium is in group 1 of the periodic table. Okay, so here go H. H has 1 electron in its outermost shell. Okay, and you don't even need to count the number of electrons. You know that 1 electron in outermost shell, that's definitely going to be a group 1, and potassium is in group 1, so that's going to be H. An atom of monatomic gas. Monatomic means group 8 or group 0. That's going to be obviously the one that has full outer shell. That's common sense, I guess. Okay, an atom of an element that is used in the treatment of domestic water supply to remove taste and odors. I guess to remove taste and odors, you should be proficient with the syllabus. That's very important. That's going to be carbon. Carbon does this thing, and carbon is in group 4. Okay, if you go to the periodic table, check out carbon going to be in group 4. And being a group 4 atom, it's going to have 4 electrons in its outermost shell, and that is E. Look over here. So it's going to be E over here. An atom that forms a stable ion by losing 2 electrons. Obviously, an atom that has to lose 2 electrons must have, because it's forming a stable ion by losing 2 electrons, it must have 2 electrons in its outermost shell, and it's going to lose these 2 electrons to form a stable ion. Okay, so this is definitely going to be D. Easy enough to think. Okay, deduce the number of protons and neutrons in the chromium atom shown. Number of protons are going to be 24. Why? Because look, you just have to dissect, or you have to look at this electronic configuration in a way that you know that this top one right here is your nucleon number. Nucleon number means that protons and neutrons combine, and this 24 is your proton number. Okay, so the number of protons are going to be 24 and number of neutrons are going to be, because this one right here is proton plus neutron. So you subtract the protons out of it, 53 minus 24, okay, and you're going to get your this electron number, whatever, this neutron number. So 53 minus 24, that gives me 29. So 29 over here. Okay, I hope you get this. Moving on. Iron is extracted in a blast furnace by the reduction of iron 3 oxide with carbon monoxide. Why is it a reduction? Because look, reduction is loss of oxygen. Over here, this iron has this oxygen with it. Okay, this O3 is attached with the iron. But over here, iron has lost its one oxygen. That is why this is a reduction reaction, because there's a loss of oxygen. This reaction is a redox reaction to the meaning of the term redox. It's in the name itself. Re means reduction. Red means reduction. RED, red, means reduction. And ox means oxidation. So redox is a reaction in which reduction and oxidation occur simultaneously. Okay? It means that both reduction and oxidation are happening at the same time. Okay, now one important thing is that how come reduction oxidation always happen at the same time? Because look, reduction is loss of oxygen. When one thing is going to lose oxygen, obviously that oxygen that's lost from one thing has to be gained by someone other. Okay, if I am losing, for example, I lose a diamond ring, obviously it has to go to someone. I lose something. If I lose it, someone has to gain it in a chemical reaction. So this oxygen that's going to be lost, someone's reduced, so someone gains it and the other substance become oxidized. Similarly, if someone's losing electrons, is getting oxidized, someone has to gain those electrons and get reduced. That's the whole concept over here. Explain how carbon monoxide acts as a reducing agent in this reaction. What's the purpose of a reducing agent? A reducing agent has to oxidize itself. A reducing agent has to oxidize itself, meaning it itself has to get oxidized. Okay, can you see the oxidation taking place over here? This carbon monoxide with a single oxygen turning into carbon dioxide with two oxygens. Okay, so gain of oxygen, it itself is getting oxidized and it's making this iron lose its oxygen, because if carbon monoxide wouldn't have been there, then iron 3 oxide wouldn't be able to lose its oxygen to someone. So what's happening is that, explain how carbon monoxide acts as a reducing agent. It gets oxidized, or you write, it basically gains oxygen to form CO2. And you can also write about this in the terms of it, it takes away the oxygen from iron 3 oxide. It takes away the oxygen from iron 3 oxide. Okay, that can also be a point. Moving on, calcium carbonate is added to the blast furnace. The calcium carbonate undergoes thermal decomposition. Thermal decomposition means that you're giving heat to a substance and that substance is being decomposed. Okay, thermal means heat, decomposition means breakdown. Okay, this is your calcium carbonate, you're heating it up and it breaks down into calcium oxide and carbon dioxide, and that's the case with most metals. But the most reactive ones like potassium, sodium, they won't thermally decompose. Why? Because their oxides or their carbonates, they're way too stable to get decomposed, because they're extremely reactive metals. Whereas less reactive metals like zinc or iron, their carbonates are going to easily decompose into oxides and carbon dioxide. Okay, the thermal decomposition of calcium carbonate is endothermic. Complete the reaction pathway diagram in figure 2.1 to show this. Okay, Now, the important thing over here is that you should know how to make a reaction pathway diagram for an endothermic reaction. What you do is that your reactants are below in an endothermic and your products are above the reactants. Why is that so? Look, endothermic means that you're gaining heat, okay? Endothermic simply means that you gain heat. And when you guys gain heat, okay, when the reactants gain heat, they form products, and the energy of the products has to be higher than the reactants because they've gained the heat. They've gained the additional heat that's basically required. So that's why your products are at a higher energy level. So these one are gonna be your reactants, and over here you're gonna have your products. Now we had to label the reactants and the products. A labeled arrow for the activation energy. Okay, activation energy. Okay, first you draw something like this. That's called the energy hump, this one right here. And secondly, activation energy is always from the reactants to the top of your energy hump. Okay, in an exo as well, when the reactants are going to be above, it's going to be from the reactants to the top of your energy hump. So it's going to be from the reactants to the top of the energy hump, something like this. And you're going to label it EA, which means activation energy. Okay, a labeled arrow for the enthalpy change. Enthalpy change is going to be from the reactants to the product, something like this, and you have to label it delta H. So done. And I guess these are the 3 easiest marks you can gain in a chemistry paper. Describe how slag is formed in a blast furnace. Include a symbol equation in your answer. Okay, now slag is formed in a blast furnace. That's an interesting concept, that what basically happens is that you've added your calcium carbonate, okay? And you just have seen over here that your calcium carbonate decomposes into calcium oxide. Now you don't need this carbon dioxide for slag formation, you need your calcium oxide. Okay, now you have formed calcium oxide out of it. Calcium oxide, what is calcium? What kind of thing is calcium? I know that calcium is a very good metal, and metallic oxides are basic oxides, okay? They are basic oxides. So my calcium oxide, which is CaO, is going to react with, what is sand? Okay, sand, what kind of formula is for sand? Sand, what is the formula for it? The formula for sand is SiO2, which is silicon dioxide. Silicon being a non-metal, okay, this is a non-metal, and non-metallic oxides are acidic. So this one right here is my acidic oxide. And when you have anywhere, you're going to find a basic oxide and an acidic oxide, so both of them are going to react together. So what happens is that your calcium oxide reacts with your silicon dioxide, SiO2, and forms calcium silicate, which is CaSiO3, which is, in common words, you call this thing as your slag. But the proper chemistry name for this thing is calcium silicate. And your SiO2, which is your silicon dioxide, is your impurity in your iron ore or hematite, and that's how you remove the impurity. You make the silicon dioxide react with your calcium oxide to form calcium silicate, which is your slag. Okay, I hope you get this thing. And that's all. Acid-base reaction you have to write. This is not a neutralization reaction. Why this is not neutralization? Can anyone of you tell me? Because in a neutralization reaction, you guys are always going to form water and salt. Okay, always water and salt is going to be formed in a neutralization reaction. So what do you call this? This is an acid-base reaction. If any one of you thinks, okay, someone of you might think that if we write this equation, will we get the mark? No, you won't get the mark. That's a decomposition equation that's already been provided on the paper. Okay, so you just had to write this equation. Moving on. Iron is a transition element. Okay, we guys know it. Transition elements have colored compounds. We know it. State 2 other physical properties that are typical of a transition element and not of group 1 metal. Okay, some of you might think that we can write they're used as catalysts, but I say that this is wrong. Why is this wrong? It seems correct because we know that we use transition elements as catalyst. But why am I crossing it out? Because that's where we guys get stuck. That's where we don't read the question properly. They've asked for physical properties. Being a catalyst, acting as a catalyst, is not a physical property, it's a chemical property. So over here, you have to write about your hardness. You have to write about your it's hard, it's strong, it forms colored compounds, and secondly, about its high melting and boiling point. That's what you have to write about. If you write electrical conductivity, is that correct or wrong? Please, I want you guys to think about it. If you write about electrical conductivity, what's it going to be? Correct or wrong? Totally wrong, because both group 1 and transition elements, both are good electrical conductors. You have to write a property typical of transition that is not in group 1. If you write electrical conductivity, that's wrong because that's in group 1 as well. Hardness is not in group 1. Group 1 elements are soft. High melting point is not in group 1 because they are typically soft, they have low density, and they're low melting and boiling points. You can also write high density because they have low density. Okay, so you have to maintain your focus on physical properties. Okay, the equation shows the decomposition of iron pentacarbonyl FeCO5 in a closed container. An important word what's happening is your decomposition in a closed container. Predict and explain what happens to the position of the equilibrium when the pressure is decreased, the temperature remains the same. Okay, you're decreasing the temperature, pressure, and you have to predict the position of the equilibrium. First thing you have to understand what's going to happen. How many moles of gases we have on this side, on this side, on this side, whatever. We are not going to take liquid and solid for pressure. We're not going to consider liquids and solids for pressure. We only see gases when we're talking about pressure, okay? We are only going to focus on gases, not on liquids, not on solids. Over here, we have 0 moles of gases, and over here, we have 5 moles. Because we are not going to count this mole. This is a solid, so we cross it out. We're only going to count the moles of carbon monoxide, which are 5. So 5 moles on this side, 0 moles on this side. Okay, predict and explain what happens when the pressure is decreased. So our equilibrium is going to shift towards the product side because we have more moles of gases on the product side. And whenever we decrease the pressure is decreased. The equilibrium is always going to shift towards the side that has less moles. So prediction, equilibrium is going to shift towards which side? This is the right side, so it shifts towards right side, or you can say the product side, or whatever. And the explanation is that more you have to write gaseous moles. If you write only moles, that's going to be considered wrong because that may mean moles of solid or liquid. So you have to write more gaseous moles, okay? More moles of gases on the product side. The reaction can be used to produce pure iron. Describe and explain by referring to the equation how a sample of pure iron that is free from FeCO5 is produced from the equilibrium mixture. Okay, you have this equilibrium mixture and you have to produce a pure sample that is free from this thing. Okay, the main distraction over here is FeCO5. Okay, look over here. What's going to happen is that if you somehow open the container, what's going to happen is that all the gas is going to escape out. And when the gas escapes out, because there's going to be focus over here, is that we have to refer to the equation. Okay, we have to include the equation. We have to look at the equation. That's a very big hint. Those of you who might be confused in a question like this, because I know it's tricky because you have to gain these 2 marks. It's tricky. You have to realize that you have to look at the equation and you have to describe and explain, okay, how a sample of pure iron that is pure, free from this thing, is produced from the equilibrium mixture. Okay, now what are we gonna do? The plan is that I need this thing, okay, and I have to somehow eliminate this and this. How am I gonna do it? Okay, but if because we know that this reaction is happening in a closed container, okay, I know it's happening in a closed container as mentioned in the question. So if I somehow open the container, what's going to happen? my my 5 CO moles, the carbon monoxide moles, because it's a gas, it's going to escape, okay? It's going to escape. And when it escapes from my container, what's going to happen? What's going to happen is that my container is going to be less of this. My equilibrium is going to be disturbed. And you know that according to the law, equilibrium always tries to reverse whatever you do to it. So if this thing escapes from my container, it means that carbon monoxide is reduced, okay? And now what will equilibrium try to do? Equilibrium will try to produce more of it, okay? So what will happen is that equilibrium will continuously be shifting towards the right, because as more carbon monoxide is being lost, equilibrium, trying to recover it, will try to produce more of it. And when it tries to produce more of the carbon monoxide, it's going to produce more of iron as well. Why? Because look, it's going to shift towards the right, and two products are going to be formed, iron and carbon monoxide. Okay, I hope you get this question. What we're going to do is just open the container, and this is going to escape, equilibrium move forward, this is going to be all used up, and our iron is going to be formed. So you just have to write it in your own words. You have to be careful about the wording, that you are going to open the container so no more equilibrium, remains stable, allowing CO gas, carbon monoxide, to escape, which is gonna indeed shift the equilibrium towards the right, and more Fe is gonna be formed, okay, is gonna be formed. And what's gonna happen then? This is gonna be reduced in the equilibrium mixture. Just write it in your own words, that this thing FeCO is gonna reduce. I hope that's clear, that how you're gonna do it. The simple concept is that when we're gonna open it, this is gonna reduce, equilibrium trying to increase it is gonna shift towards the right. Iron reacts with hot concentrated sulfuric acid. Okay, the products are iron 3 sulfate, sulfur dioxide, and a liquid that turns anhydrous copper to sulfate blue. Okay, now we know some products that are iron 3 sulfate. We just have to form a formula. We know the formula for sulfur dioxide, SO2. And the third thing is that we have a liquid that's going to turn our copper sulfate blue. What kind of liquid are we talking about over here? What kind of liquid are we dealing with? We're dealing with simply water. Don't you remember the test for water? The test for water is that put a few drops of it on anhydrous copper to sulfate and it's going to turn blue. That's the test for water. Okay, construct the simple equation for this reaction. The simple equation is going to be that iron is reacting with concentrated sulfuric acid. So our reactants are going to be iron, which is Fe, and sulfuric acid. So it's H2 and SO4. Okay, the hot and concentrated part, we don't have to add it in our equation. Okay, so because it's a simple equation, so what we can do is that in front of iron, we can write solid, something like this, and in front of sulfuric acid, we can write aqueous like this. Aqueous means it's dissolved in water, because all acids are dissolved in water. Okay, acid is basically formed, that acidic hydrogen ions are basically discharged when you dissolve it in water. Okay, so now you've taken these two, and what you're going to form is iron 3 sulfate. How do you write iron 3 sulfate? It's going to be Fe2SO4 3. Do you get me how I've written it? If you don't get me, I'm going to explain it again. Okay, the charge on iron is 2 plus. Okay, the charge on iron is 3 plus. Sorry, 3 plus. And the charge on sulfate, because this is 3, I'm so sorry. And the charge on sulfate is 2 negative. Okay, this 2 negative comes underneath iron 2, and this 3 comes under sulfate. So it's going to be written like Fe2SO4 3. Okay, and the next thing we're going to form is sulfur dioxide, which is SO2 gas, and we're going to form water, which is H2. Now comes the important part, that's balancing. Let's see how we're going to balance it. So now let's solve this equation by ABCD method. Okay, it's a very easy method which guarantees you your marks. Okay, sometimes in an exam hall, we guys are panicked, we're afraid, we're trembled, and we're unable to think of the correct balanced form. Okay, sometimes we're unable to think how 2 we apply, where we apply 3, and whatever, and some people are not good at it. to be on the safer side, we use ABCD method. It's a method that's going to guarantee your answer every time you apply it, and that's the guarantee it gives. That's why it's safer to use this method when you are unable to find an answer, and when it's a difficult equation that looks something like this. So what do we do in ABCD method? First, we write simple ABCD. We write A, B, C, D, and E. Okay. Now what do? The next thing that we're going to do is we're going to count the number of A's over here, meaning how many iron we have. We have 1A because we have 1 iron. So we write 1A equals to how many iron we have on the other side of equation. We have 2 irons. Okay, this is Fe2. So we have 2C. Okay, so 1A, 1 iron on this side equals to 2C. Okay, because 2 irons on this side. Next, we count for hydrogens. How many hydrogens we have? We have 2 hydrogens, and hydrogen is with a B. So 2B equals to 2E, because look, we have 2 hydrogens on this side as well. So 2E. Next, we look for sulfurs. How many sulfurs do we have on this side? We have 1 sulfur. Okay, 1 sulfur. So 1B equals to how many sulfurs on this side? Okay, we have 1 sulfur for D. So 1D plus we have 3 sulfurs on this side. To get 3, and in bracket we have this sulfur. So 3 sulfurs on this side. So 3C, because C is the coefficient of this sulfur, plus 3C. And the next thing we do is we look at our oxygens. We have 4 oxygens. So 4B equals to how many oxygens in this equation? We have 12 oxygens, because 4 over here and 3 over here. So 4 multiplied by 3 equals to 12. So we have 12 oxygens. So we're going to write 12C plus, over here we have how many oxygens? 2 oxygens plus 2D, because the coefficient is D, and 1E plus 1E. Now, step number 1 is complete, that we just had to dissect these equations and write them over here. Okay. Now, step number 2 is that we take an alphabet which is most commonly appearing in all the equations. Over here, I see that A is only appearing once in this equation. C is only appearing twice in these 2 equations, and thrice over here. So C is appearing 3 times. Okay, C is appearing 3 times, and B is also appearing 3 times. So now it's my choice that either I take C or I take B. So for this question, I'm gonna personally take B. Okay, randomly I'm taking B. So the step is that you have to take the alphabet that is most commonly appearing. Okay, that is most commonly appearing. So over here I have taken B. Now what do I do with this B? What I do is that I make it equal to 1. Okay, so now my B, that's my most commonly appearing, equals to 1. So in all these equations, in all these 3 equations, I put my B equal to 1. So let's see what I do. So 2B equals to 2E. I've just copied this equation over here. I put my B equal to 1. So 2 times 1 equals to 2E. 2 equals to 2E. 2 upon 2 equals to E. 1 equals to E. So E equals to 1. Now I have the answer for E and B. Next equation that I'm going to choose is, I'm going to choose this equation. Okay, 4B equals to 12C. I have value for B, which is 1, so I'm going to put 1 instead of B, equals to 12C plus 2D. I don't have value for D, plus 1E. I have value for E, which is equal to 1. So 1E means 1 times 1. Okay, 4 equals to 12C plus 2D plus 1. 1 goes on that side, it becomes 4 minus 1, which becomes 3. So 3 equals to 12C plus 2D. And now what I do is that this is my one equation. Okay, this is my one equation, and I have two alphabets in it. So what do? I have this equation, it also has two alphabets, D and C, and this one also has D and C. So I'm going to simultaneously solve these two equations. So 1b equals to 1d plus 3c. So 1b equals to 1d plus, I'm copying this down, plus 3c. b equals to 1, I've just written it over here. B equals to 1, I took b as 1. So 1 times 1 equals to 1d plus 3c. 1 equals to 1d plus 3c. I write it over here. 1 equals to 3c plus 1d. Now I have these two equations. I want to solve them simultaneously. What I do is I just cancel out any one of them. Okay? I cancel out any one of them. So what shall I do? I guess I should do, if you know how to solve simultaneous equation, we're going to multiply this entire by -2. Okay? This entire equation, this second one, by -2. So I write the upper one as it is, 3 equals to 12c plus 2d, and the one I multiplied by -2 is -2 equals to -6c -2d. And now my -2d gets eliminated. Okay, I'm just doing simultaneously. I know this might feel difficult, but it's going to guarantee an answer. 1 equals to 6c. So 1 equals to 6c, that means c equals to 1 upon 6. I know it might look confusing. Just wait, we're going to get everything sorted out, and this is the easiest method that you've learned until so far. Okay, 1 upon 6 equals to c. Now we have value for c as well. We simply put in our value for c in this equation, in any of the two equations. 1b equals to 1d plus 3c. Let's put it. 1b equals to 1d plus 3c. c was equals to 1 upon 6. So 1b, b is also 1, equals to 1d plus 3 multiplied by 1 upon 6. 3 1 times, 3 2 times. So 1 equals to 1d, mean d plus 1 upon 2. This 1 upon 2 goes there, and it becomes, wait a sec, move this here, we move this thing underneath it, and let's solve it. So it becomes d equals to 1 minus 1 upon 2, and d equals to 1 upon 2. Okay, I hope you get it. And the value for d comes out to be 1 upon 2. So d equals to 1 upon 2. And now for a, we have to find out 2c equals to 1a. So what is the value of c? C is equals to 1 upon 6. So 2 times 1 upon 6 equals to a. 2 1 times 2 3 times, a equals to 1 upon 3. A comes out to be 1 upon 3. Now let's plug in the values. A is 1 upon 3. So a right here is 1 upon 3. B here is 1. So instead of b, I put a 1. C is 1 upon 6. C is 1 upon 6. D is 1 upon 2. 1 upon 2, and E is, where is E? E is also equal to 1. Okay, now we've got the values. Now the last step and the easiest step is, now we cannot write equations, balance equations like 1 upon 2 and 1 upon 6. So what we take the biggest number, which is 6. We had how many fractions we have? We had one with 3 denominator, one with 6 denominator, one with 2 denominator. So we take the fraction that has the biggest denominator, that is 6, and we multiply the entire equation with its denominator, because we multiplied by 6, this is going to get cancelled, and this becomes a1. So everything gets multiplied by 6. We are multiplying the entire equation by 6. So multiplied by 6, 1 multiplied by 6, 1 upon 6 multiplied by 6, 1 upon 2 multiplied by 6, and 1 multiplied by 6. So when this get multiplied by 6, 3 1 times, 3 2 times. So, and 2 1 times 2. So the answer comes out to be 2 over here. So the answer is 2. And when this get multiplied by 6, 1 6 times is 6. So this is 6. And 6 1 times 6, 6 1 times 6, this comes out to be 1. So What was this? This was Fe. Okay. Next, 2 1 times, 2 2 3 times. So the answer over here is 3. 3, and this is SO2. And over here 1 6 times is 6. So 6. And the equation is balanced. I know it took some time, but this was the first time. As you practice, it's going to become easier and easier, and this is exactly the correct balancing. We didn't have to think anything, we just had a formula like this. We had to apply a formula and little bit of maths. We just had to use simultaneous equation, and we got the correct balancing. I guess that in exam, if you are unable to think of, you should know this method. This method is a definite to know, because sometimes you are unable to balance. To get definite balancing like this, which involves 6 and 3 and 6 and 2, this method is really helpful for me. At least when I use this, I know there's a guarantee to my answer, 100% correct answer. Okay, moving on. Figure 3.1 shows the apparatus used for electrolysis of concentrated aqueous sodium chloride using graphite electrodes. Okay, so what we have is concentrated aqueous sodium chloride. Firstly, it's concentrated, so what we're going to form is chlorine gas. Okay, when we have concentrated, we always form the halogen. And secondly, we have aqueous. Aqueous means that out of the metals, we're going to form hydrogen. Okay, at the negative, we're going to form hydrogen, which is the cathode. Okay, at the cathode, we're going to form hydrogen. At the positive, we're going to form chlorine. Label the cathode on figure 3.1. We've just labeled it. This one's the cathode. Explain why concentrated aqueous sodium chloride conducts electricity. Concentrated aqueous sodium chloride. Okay, now here comes the concept that when you have a simple ionic compound, which is NaCl, in a solid form, it won't conduct, because Na ions and Cl negative ions are stationary, means fixed in their position, so they're unable to move. But when you have aqueous sodium chloride, it means the ions are dissolved in water, so they're able to move. So we're going to write because it has mobile ions. That's simple. Name the product formed at cathode. We just discussed it, that it's going to be hydrogen. Why hydrogen? Why not sodium? Okay, why not sodium? Because sodium is above hydrogen in the reactivity series, and when it's above, it won't be able to discharge as quickly, so hydrogen's going to discharge at the cathode. Okay, chlorine is formed at the anode. Okay, that's what we know. Construct the ionic half equation for the reaction at the anode. So we have chlorine negative ions. Okay, chlorine negative ions, they have this additional electron, so they have to lose it. So chlorine is going to lose the electron, and it's going to form Cl2 gas. Because it's a gas, we write 8 2 over here. That's important because it exists in molecular form. Plus 2 electrons it has lost, so we need 2 chloride ions. When they're going to lose, each one's going to lose 1 electron. In total, we're going to have a loss of 2 electrons, because we have 2 ions and each ion is going to lose 1, and we form Cl2 gas. Okay, graphite is suitable as an electrode because it conducts electricity. Okay, it conducts electricity. State one other property of graphite that makes it suitable for an electrode. Graphite is inert. For example, if it was not inert, what would happen is that over here chlorine is formed. Okay, Cl gas, and Cl gas is extremely reactive. So if this graphite was not inert, this gas would entirely react with the graphite, and your graphite, your whatever metal was it would be used up. So we have to make our electrode of a metal that is completely inert, that does not react with the product that's being formed. Okay, otherwise we would have to use a lot of money to replace it again and again. State the product formed at the cathode when molten. Molten means it has no water. It's melted sodium chloride, not aqueous. Aqueous means it has water. Molten means no water. And when it has no water in it, means no H plus ions. Okay, no water, no H plus ions, so only positive ions we have are sodium, so they have to discharge this time at the cathode, because cathode is your negative electrode. Okay, state the product formed at the cathode. It's going to be sodium this time because we have no hydrogen. Okay, this question is about alkanes and alkenes. Okay, P21 belongs to the alkene homologous series. I guess we know it. It's an alkene because it's an ene over here and it's an ene over here. Okay, members in the same homologous series differ from one member to the next by 1 methyl unit. This is a methyl unit, a CH2 unit. Okay, and they have similar chemical properties. They've given us 2 properties of a homologous series, 1 methyl unit and similar chemical properties. State 2 of the characteristics of a homologous series. That's as easy as ABC. Same, they have the same general formula. They have the same general formula. And secondly, they have a trend in physical properties. They have a trend in physical properties. And if you want the third one, that is that they have the same functional group. You can only write these three. Why? Because the other two are given in the question. Don't try to outsmart the examiner by writing this and this, because then you're going to get a 0 on 2. Okay, figure 4.1 shows the displayed formula of but1-ene. Why it's but1-ene? Because the double bond, the ene bond, is on the first carbon. Okay. Explain how figure 4.1 shows that but1-ene is unsaturated. Unsaturated means that it has a carbon-carbon double bond. Okay. It has a carbon-carbon double bond. Okay. Give the structural formula of but1-ene. That's simple. How do you write the structural formula? First, you write CH2. You start from this side or that side. That does not matter. You write CH2. Then you write this thing, CH. Double bond CH. Okay? You have to make double bond in structural formula. Then you write this CH2, and then you write this CH3. So you're done with your structural formula. Don't expect an examiner to give you marks if you have not mentioned the double bond. Okay? Don't expect the examiner to give you any mark if you have not mentioned the double bond over here, because this tells us that this is but1-ene. Draw the displayed formula of an isomer of but1-ene. An isomer of but1-ene, What do you think an isomer of but1-ene is going to be? but2-ene. You have to think about these things. Isomers. These are not functional group isomer. These are positional isomers. You're changing the position of the functional group. Over here, the double bonds on the first carbon. Over here, the double bonds on the second carbon, because it's but2-ene. So firstly, we draw 4 carbon because it but. Now we draw a double bond on the second carbon. Okay? We count from here, it's 1, 2. This one's second carbon. If we count from the other side, it's 1, 2. It's the second carbon. We have the double bond on. Now we just fill the remaining places with hydrogens. Okay? Hydrogen, H. Some people might think, why I have not drawn a hydrogen over here? Very good question. Because carbon has a valency of 4 and it has made its 1, 2, 3 and 4 bonds. So it cannot make this 5th bond, otherwise it's going to be wrong. And this one right here is your but2-ene, because ene part on the second carbon. Okay. Undecayed C11H24 is present in kerosene. Okay. Fraction from the distillation of petroleum. Give one use of the kerosene or paraffin fraction. Kerosene is basically used as your jet fuel. You have to learn these from the syllabus. When undecayed is cracked, shorter hydrocarbon molecules are formed. Okay, construct the simple equation for a reaction in which undecayed is cracked and the only products are butane, propene and ethane. Let's draw it. Okay, we have C11H24. We're cracking it, and the only product we're forming is butane. Butane is C4H10, one alkane, plus propene, which is C3H6, one alkene, and another alkene, which is C2H4. So let's balance it out. We have 4, 5, 6, 7, and 8, 9. We need 2 more carbons. So in order to get 2 more carbons, we're going to put a 2 over here. Now carbons are balanced, and check out the hydrogens. 18 okay, and plus 6, that's 24. So we're done with this thing. I hope you get it that we had to balance it out as well. We didn't just had to form the products. 1 mark was for the products, that was butane, propene, ethene, and 1 mark was for this to balance it. Okay, propane reacts with chlorine to form chloropropane and one other product, X. You should know this. This is a substitution reaction. You're going to form HCl. I guess that's as easy as ABC. Okay, this is hydrogen chloride. Okay, don't write hydrochloric acid. That's going to be incorrect. You don't say this is hydrochloric acid. This is a hydrogen chloride gas. Hydrogen chloride exists in gaseous form. It's a gas, and when you dissolve it in water, it forms hydrochloric acid. Don't say hydrochloric acid is formed. That's wrong. You form hydrogen chloride. Okay? State the essential condition for this reaction: UV light. Why? Because it provides the activation energy for the reaction, which is the minimum amount of energy that the colliding particles must have in order to react. Up. A student adds large pieces of copper 2 carbonate to dilute HCl. Okay, the copper 2 carbonate is in excess. Complete the equation by adding state symbols. CuCl2. All chlorides are soluble except lead, silver, and lead and silver. Only lead and silver in our syllabus. And so copper is going to be soluble. So AqH2 is a liquid and CO2 is a gas. Simple as it is. Figure 5.1 shows the mass of the reaction mixture changes with the reaction. Why is it decreasing? That's simple. We're forming carbon dioxide gas and the gas escapes. So in another experiment, powdered copper 2 carbonate is used instead of large pieces. Okay, if you're using powder instead of large pieces, that means that you're going to have a faster rate of reaction. You have faster rate, a higher rate. Okay, all other conditions are kept constant. Draw the line to show how the mass of the reaction mixture changes. Okay, so now our line this time is going to be a bit quicker. We're going to reach the no, it's not like this. It's going to be something like, it's going to be a bit faster and we're going to reach the line. No, not like this. It's going to be something like this. Okay, don't forget that you don't have to basically change the amount of the product. Okay, you don't have to change this, you just have to make it a bit faster. Okay, the initial experiment is repeated using large pieces of copper 2 carbonate and hydrochloric acid of a higher concentration. All other conditions stay the same. Describe and explain the difference in the rate when hydrochloric acid of higher concentration is used. Okay, so when we're increasing the concentration, what's happening is basically we're increasing the number of particles per unit volume. Okay, initially the number of particles we have are less, but when we increase the concentration, it means that we have more particles in the same amount of volume. So the volume, the container, the amount of the acid remain the same. Now there are more particles, hence the reactants will collide more frequently with each other. And when they're going to collide more frequently, the product's going to be formed at a faster rate. So this understanding is very important, that when you're increasing the concentration, increasing the number of particles. So what's going to happen? Explain the difference in the rate. Rate's going to be faster, the first mark, and secondly, why? Because more successful or effective or whatever, more successful frequency of collisions. Okay, higher frequency of effective collisions. Effective collision mean that the product is formed, because every time the reactants collide, the product is not formed. Only when the reactants collide with enough energy that's equal to the activation energy, the product's going to be formed. Okay, you get it? The excess copper 2 carbonate is added to this hydrochloric acid. Calculate the volume of carbon dioxide released, measured at RTP, give the answer to two significant figures. Okay, so the very, very, very important thing is the equation which is given in the question. We know that what is happening is that in the equation we have the moles. Moles are the most important thing. 1 mole of this, 2 moles of this, 1 mole of this, 1 mole of this, and 1 mole of this. Okay, now we have the moles. That means that we've got everything that we know. We know 1 mole of copper carbonate going to react with 2 moles of hydrochloric acid to form 1 mole of copper chloride, 1 mole of water, and 1 mole of carbon dioxide gas. So let's figure out whose moles can we find out. Now we're given with this is the volume, and this is the copper carbonate is added to, this is the concentration conc of HCl. So we can find the moles of hydrochloric acid. Okay, so moles equal to our volume multiplied by our concentration. So volume is basically 24 and it's in cm cube, so we're going to divide it by 1000 because we got to have the volume in dm cube, multiplied by concentration, which is 0.500. So 22 divided by 1000 multiplied by 0.011 equals to 0.011 moles. These are the moles of HCl, and now we can form a ratio because 2 moles of HCl gonna form 1 mole of carbon dioxide. Okay, so we form a ratio something like this, that we have HCl ratio CO2. 2 moles of this gonna form 1 mole of this, so 0.011 moles of this gonna form x moles of this. X equals 2, we simply cross multiply and we get 0.000055. Now we have the moles of carbon dioxide, and simple, we have to find the volume equals to moles time 24 if we want to find in dm cube. If we want to find in cm cube, so mole times 24,000, so moles time, which is 0.0055 times 24, so times 24, 0.132 dm cube. Describe the observation that is made. A few drops of aqueous ammonia, okay, ammonia is an alkali, are added to aqueous solution containing copper ions. Okay, ammonia, copper 2 plus ions. What's going to happen is that ammonia, which is NH3, and copper 2 plus ions are Cu2 plus. Okay, I hope you get this thing. Now what's going to happen is that you are adding an alkaline ammonia to a solution which has copper 2 plus ion, and you have to write the observation. What's going to happen is that, because look, it's an alkali and these are copper ions, so what basically happens is, you've also read in you have learned in the salt analysis that when you add ammonia to copper ions, what happens is that what kind of precipitate you forms? Light blue precipitate. So that's going to happen, and these precipitates, when you have excess ammonia, they dissolve to form a dark blue solution. So what will happen in excess ammonia? The precipitates dissolve, and it's a very important observation you have to write, to form a dark blue solution. Okay, so that's it. An ionic compound of copper has the formula Cu2O, reduced oxidation number of copper in it. Obviously A plus 1. Why A plus 1? Look over here. Oxygen has a 2 negative. To balance out a 2 negative, you need a 2 plus. Okay, and 2 coppers combined have a charge of 2 plus, so one will have of 1 plus. Okay, I hope that's clear. Describe how to prepare crystals of ammonium chloride, which is a salt, by reacting aqueous ammonia with dilute hydrochloric acid, because this salt is extremely soluble, and the two reagents that we're using, ammonia and hydrochloric acid, are also very reactive. So what we're going to use, the method is not excess method. If you use excess method over here, it's going to be a complete cross. What you're going to do is titration. So you just have to write the steps of titration, that you take something in conical flask, you take the other thing in burette, then you add universal indicator into it, and after that what you do is, look, you have this conical flask for titration, then you have this burette kind of thing, okay, and you take one liquid, I say ammonia, in your conical flask, and you take your HCl in your burette, and then you add drop by drop HCl into it once, and you also add 2 to 3 drops of not universal indicator. You use any kind of indicator. For example, I use litmus. You use litmus, or you use methyl orange, or phenolphthalein, or bromotyl blue, whatever, methyl orange. Okay, and when you've added the indicator, what's basically going to happen is that when the indicator changes color, you add HCl drop by drop. That is your end point, and when you reach the end point, now it's time to stop. You stop your titration, you note the volume of your HCl over here, and now you repeat the titration without the indicator, because the indicator basically makes your salt impure, and now you're going to repeat it without the indicator, and then you're going to get a pure salt. You crystallize it then. Okay, to get pure dry sample, you just have to write whatever I told you. Okay, just the steps. Next, figure 3.1 shows the structure of zinc sulfide and disulfur dichloride. Zinc sulfide has the structure similar to diamond. Why? They've told us this to make us realize that this thing is a giant ionic compound. Okay, this is a giant ionic compound. Okay, explain why zinc sulfide does not conduct electricity. Why diamond does not conduct electricity? Just think about diamond, because no mobile electrons. Diamond does not has any mobile electrons. All 4 electrons are used to form bonds. Okay, because carbon has a valency of 1, 2, 3, 4, and all these 4 are forming bonds. That's why. Predict one of the physical property of zinc sulfide, that's of diamond. High melting point, same as diamond. Okay, explain why disulfur chloride has a low melting point. Why? Because it is a simple ionic, not simple ionic, simple molecular structure, but they've not asked us to explain in terms of structure, they've asked us to explain. That is because of the weak intermolecular forces of attraction between the molecules. Okay, because it's a simple molecular structure, it's going to form molecules, and there's going to be weak force of attraction between the molecules. That is why your simple molecular substances like oxygen, your I would say your oxygen gas, your chlorine gas, your ammonia gas, your methane gas, they have low melting and boiling points because they have weak force of attraction between their molecules. Okay, now we've just completed. What we're gonna do is, because sulfur, it has a valency of 2, so one bond over here we're gonna complete, one bond over here we're gonna complete, one bond over here we're gonna complete, and rest we're gonna complete like this. And 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. One important thing, we erase it and make it a cross. Why? Because all sulfur we have shown crosses, and for chlorine we have shown these dots. Okay, all valencies are fulfilled, and we have shown all outer electrons. You don't only just show the bond, show the lone pairs which are unbonded as well. Okay, now we have this question which says that we have 13.5 gram of disulfur dichloride with 8 grams of water, and we have to show by calculation that what is in both of their moles. Okay, first we know that 1 mole of this is going to react with 3 moles of water. So let's find out the moles of disulfur dichloride. How are we going to find out the moles? Simple, use the formula that moles equals to our mass upon mr. So first let's find the mr. Mr is going to be that we have 2 sulfurs, 1 sulfur is 32. So 32 plus 32 plus 35.5 plus 35.5. So it's going to be 32 plus 32 plus 35.5 plus 35.5, and that gives me 135 as my mr. So my mass is 13.5, my mr is 135. Let's find out the moles. So 13.5 divided by 135, and that gives me my 0.1 moles. Okay, now I have 0.1 moles of my H2Cl2. Okay, now look over here. Try to look over here and understand what I tell you to guys. Look, I have 0.1 moles of my this thing. Okay, I have 0.1 moles. Now, according to my ratio is 1:3. Okay? That means 1 mole of this thing is going to react with 3 moles of this thing. If I have 0.1 moles of this thing, it means I need 0.3 moles of this thing. Now, let's check which one is in excess, because I need 0.3 moles of this thing. Okay? If I have less moles than 0.3, then that means that this is in excess, and if I have more than 0.3, that means this is in excess, because I need exactly 0.3 of water. Let's find out the moles of water. Okay, now the mass of water is 8 grams and mr of water is 16, 17, 18. So 8 divided by 18, it's going to be 8 divided by 18. I get 0.444 moles. Okay, I get 0.44 moles. I only needed 0.3 moles, but I have 0.44. That means that my water, which is my H2O, is in excess, and I need to show all this working, and I have to tell that I needed 0.3 moles, but I have 0.44, which means H2O is in excess. Sulfur dioxide is an air pollutant. State one adverse effect of sulfur dioxide, because it's an acidic gas, so it is going to cause acid rain. Describe 2 ways reducing emissions of sulfur dioxide in the air. Okay, first thing you can do is you have to reduce the emission. It's not about that some people might say that use what is that thing, use catalytic converters. okay, that's kind of correct, but you have to reduce the emissions. Catalytic converter is more for nitrogen oxides. Okay, don't say catalytic converter. First you can use is flue gas desulfurization. Okay, that's going to reduce your emissions. And secondly, you're going to use low sulfur fuels. Okay, these are the two requirements that I mentioned in your syllabus. Okay, learn the syllabus and that's going to be easy. Okay, propanoic acid can be represented by this formula. Propanoic acid reacts with methanol, which is CH3OH, to produce an ester. Okay, what's going to be the name of the ester? You have propanoic acid and you have your methanol, so it's going to be methyl. You take the name of the alcohol and then propanoate. Okay, methyl propanoate. Okay, I guess that's simple. If you have to draw the displayed formula, it's going to be wait, we can make the alcohol first like this, and not alcohol, the acid first. So the acid part is methanoic, and over here we can attach our O, then C, because it is methanol, it's going to be like this, C, and here you come with your H. Okay, so this is your methyl propanoate. Okay, this is your methyl part, this is your propanoic acid part. Okay, propanoic acid is a weak acid. Explain how the equation shows that. Okay, this is a very important concept that's been recently added, that acids are proton donors, alkalis are proton acceptors. Okay, bases are proton acceptors, alkalis are forms of bases. Okay, this is an acid by referring to proton transfer. Why? Because look, it is getting a 1 negative charge. It has transferred this H to water, so it become H3O and it has got 1 positive charge. So you write it donates a proton to water. And why it is a weak acid? The main the thing that tells us it's a weak acid is this sign. This reversible reaction sign tells us it's a weak acid. It partially dissociates. This tells us it partially dissociates. That's why it's a weak acid. Propanoic acid reacts with magnesium. Name two products of this reaction. Okay, you have your magnesium, which is Mg. Okay, and then you have your propanoic acid, which is an acid. So magnesium is a metal and that's an acid. So metal plus acid is going to form you salt and your H2 gas. So the one thing is going to be hydrogen, and secondly the salt is going to be magnesium propanoate. That's going to be the name of the salt. Okay, because you have magnesium and propanoic acid. Okay, and then we have magnesium as a solid. Okay, now we have solid. We have to describe the motion and separation of solids at room temperature. So the motion is going to be that they vibrate about their fixed positions, because in solid they cannot move. Okay, and the separation is going to be that their particles are touching each other. Why touching each other? Because they're so close to each other that they're touching. That's very important. Separation is how separate are the particles, and the touching is exactly the best word for it, I guess. Figure 7.1 shows the simplified structures of two molecules that combine to form a polyamide. Okay, we have a polyamide that's a dicarboxylic, because we have two carboxylic groups, and we have a diamine that because we have two amine groups. And when we have diamine and dicarboxylic, we form nylon, not proteins. For protein we need amino acids. Okay, complete the diagram to show the structure of two repeat units of this polyamide. Okay, now we have to show two repeat units only, so that means you have to draw extension bonds, something like this. And okay, this one we have to be careful that this dotted one is dicarboxylic, and the blank one is diamine. So we start with diamine. One H is gone to form water. Over here OH is gone to form water. Just cross it out on the diagram. Just let me just clean it. And now let's see. To form water, we're going to take OH, we're going to take H, we're going to take OH from here and HO from here. So now we just start with forming this. We have N, we have H. Over here we're going to have N, we're going to have H. This is going to be bonded to a C double bond O. Over here C double bond O, N, H, N, H, C double bond O, C double bond O. And over here we have some extension bond. That's going to be it. Moving on, polyamides or polymers. State the meaning of the term polymer. Polymer are long chain molecules that are built up of smaller molecules called monomers. So they are long chain molecules, okay, built up of smaller, you can say repeat units. Okay, repeat units called monomers. Okay, polyamides or condensation polymers state one difference between a condensation polymer and an addition polymer. Simply, the easiest difference is that an addition polymer is going to have the same, the empirical formula as the monomers. Whereas a condensation polymer, because you're losing water or HCl or whatever, you're losing something. So the empirical formula is going to be different than the monomers. So in addition polymer, you have same empirical formula as the monomers. Okay, but in condensation polymer, the empirical formula is different. Okay, I hope you understand this. If you want to write other difference, it can be that addition polymer is formed when you have a double bond, a carbon-carbon double bond you need, whereas in condensation polymer you don't need a double bond, you just need the active parts. So there are many differences which you can think about, but this one's the simplest one. I hope you understand, and that's it for today. Bye-bye.